Hi everyone, today we're going to have a look at quadrilaterals and see if we can add that to our geometric knowledge. So to start with, a quadrilateral is a four-sided shape. The internal angles of a quadrilateral add to 360 degrees, and quadrilaterals are named by their features, angles, parallel edges, and the length of the edges. So here we have a square. It has four edges, as per every other quadrilateral. The edges are all equal length, and the internal angles are all 90 degrees. And this length is parallel to this, and this length is parallel to this. Similarly, with a rectangle, this length is parallel to this one, and this length is parallel to this one. These two edges are the same length, and these two edges are the same length, but different to a square. This edge is different length to this edge. A rhombus is like a squashed square. The four edges are all the same length, but this time the opposite edges are equal, but the opposite angles are equal, but the adjacent angles are not. In a parallelogram, we have this side being parallel to this side and this side being parallel to this side. No real difference between a rhombus and a parallelogram is that the adjacent edges are not the same length. I think I've completely stuffed this up. No, I haven't. All's good. This angle here is the same as this angle, and this angle here is the same as this angle, similar to a rhombus. But now just the adjacent edges are not the same length. With a kite, we have effectively, if we drew a diagonal here, two isosceles triangles on top of each other. So this edge must be the same length as this edge, and this edge must be the same length as this edge. This edge is not the same length as that edge. If it was, it would be a rhombus. And these two angles will be the same. These two angles are going to be different. Now, a trapezium, its only real property is that it's got four sides and one pair of parallel lines. So we can use these properties to solve problems. Here are a few. The first one's a parallelogram. We've been given that this angle is x and this angle here is 2x. Given that it's a parallelogram, this angle and this angle are the same, and this angle and this angle are the same. So we have two of these and two of these, which is what's been stated here. Two lots of x and two lots of 2x. And they must add to the sum of the internal angles, which is 360 degrees. So if we simplify the left-hand side, we'll get 6x equals 360, and x must be 60. Now the critical part is that we give reasonings for anything that we're doing, so we don't just write down a number salad. The internal angles of a parallelogram is 360 degrees, that's why that works. And the opposite angles of a parallelogram are equal, which is why this works. Then we just simplify. In the second case, we have a rectangle. The rectangle has four internal angles, all of 90 degrees. We've got three of them here. This remaining one must be 90. So we've stated that each internal angle in a rectangle is 90 degrees. This angle here is stated it's x plus 10. If that's the case, if we subtract 10 from both sides, we'll get x equals 80. Solved. Here's that kite problem split into two isosceles triangles. We've been given 60 degrees, 2x and x, and been told that this side and this side are equal length, and this side are equal length. That being the case, if that's 60, the base edges of an isosceles triangle are equal. So if that's 60, this angle over here, which I've called z, also has to be 60. That's what I've stated up here, and there's the reason. Once we know that, 60 plus whatever this is, has to be 180. Well, that's an equilateral triangle, in fact. So we now know that that length is the same as that because it's got three angles of 60 degrees. But more importantly, if that's 60 degrees and 2x, 2x must be 30. If 2x equals 60, x must be 30, which is what this says here. Now, once we know that x is 30, we can put it up here. This again is an isosceles triangle, so we can use that to find the base angles. Take the 30 away from 180 and halve it, which gives us a equals 75. So if that's 75, this one over here must also be 75. Now that we've found out a and z, we can find out y by adding them together. Y equals a degrees plus z degrees. This angle is 60. This angle is what do we say it was? 75. So 60 plus 75 is 135 degrees. And there we are. We've solved the problem and we've done some decent working, at least for year 7. Okay, well, if that's been helpful, I will see you next time. Thank you, everyone.